right, so as was mentioned, my presentation is focused on the improvement of the codex protein clusterings that are on the HuBMAP data portal. So to begin with, just an overview, the focus of this project was analyzing and improving these protein clusterings that are available. And the objective, the end goal for this project was to create a Jupyter notebook that can function as a template for users to perform similar analyses. And this notebook would be uploaded to the HuBMAP workspaces. Moving on for a bit of introduction. So the HuBMAP data portal utilizes codex data that is targeted binding of antibodies to antigens to obtain information about protein levels. And then this is processed using the SPRM pipeline, which performs k-means clustering based on various attributes related to the proteins. Our aim was to obtain biologically meaningful clustering, as HuBMAP's goal is to provide this information, so clusters should be as accurate as possible. So what we wanted to examine is this current method effective, and exploring some potential ways to improve the quality of these clusterings. As can be seen over here on the right, some of the test visualizations of a certain tissue sample featuring two different clustering methods. The bottom one here, which is based in total expression levels of the proteins, is the one that we focused on trying to improve. So we used one specific process codex data set from the large intestine, and started by attempting to recreate a part of the SPRM pipeline's output. So clustering based on total protein intensity, as I mentioned, using 3 clusters initially, as was used in the pipeline output, and no pre-processing, no scaling. And from there, we went on to test a range of K parameters, starting from 3 going all the way up to 12 to capture different clusters within the range of the number of expected cell types within a sample. And we also applied various types of scaling within the code, starting with min-max scaling and then trying z-scaling, or also known as standard scaling, and creating a function that could take just a subset of the proteins within the sample. So here is a picture of the main clustering function that is in the Jupyter notebook of the code. This will be eventually uploaded to workspaces once it has been refined and completed. So in terms of results, first off, our recreation of the SPRM clustering, which looks pretty much the same as the one that was shown previously. As you can see, most of it is colored the same. It's pretty much largely every cell being categorized into one cluster, which was not ideal, thus us trying to create more specific clusters. Next, when we added min-max scaling to the pipeline, this resulted in these very evenly distributed clusters along the x-axis, so these stripe patterns that did not seem to be very biologically significant. It didn't seem like they were being properly grouped. So From there, we then looked at different types of scaling and found in a paper on the topic that z-scaling was largely considered to be one of the best for accuracy. And when we applied this and also increased the number of clusters, here we used 10, which may be too many or too few. We still need to refine that. But there is a marked improvement in the quality of the clusters. As you can see, the outer edge is being grouped together more as opposed to the interior of the sample, which is more what we would expect. And yes, increasing the number of clusters definitely also helps. You can see the difference in the distinction between the original versus where we are at around now. And so from this, we've determined that implementing this z-scaling and using a slightly larger number of clusters will create more informative protein clustering results. And it should be noted, though, that further testing will be required to verify this method's usefulness and to better refine it. So as a result, since I have 2 weeks left with the HiDive lab, I have a few upcoming goals with that, such as testing with some other data sets, looking more into how to validate the quality of our clusters, and working on being able to optimize K, or the number of clusters, for the different data sets, and of course, getting this notebook uploaded into workspaces. For future directions that could be continued even after my work with the lab is complete, there's a lot more that can be done to continue refining this information, such as trying out all these different methods, like other scaling techniques, seeing the effects of subsetting, and focusing on only a few of the proteins out of the data set, which we have done a little bit of, but not much. Continuing to test using different data sets that are available on the HuBMAP data portal, searching for ways to benchmark quality, which can be a bit difficult as there is not much literature at this time on this particular subject. Additionally, in my experience using the HuBMAP workspaces, I have a couple of suggested improvements to their functionality and efficiency due to issues that I've run into, such as resolving some issues related to uploading local files, as even smaller size files for some reason would not upload from my computer. And also continuing to improve availability and loading times, which can be rather long at the moment, which makes it not exactly ideal for people hoping to use the workspaces to do analyses. I'd also like to take a moment to reflect on this internship and everything that I have gotten out of it from working with the HiDive lab team. This has been an excellent opportunity to improve my skills with Python coding and data analysis. And it's also been a great opportunity to practice managing my time working independently, as well as communicating with the team, doing weekly check-ins, weekly meetings, and balancing collaboration and trying to get things done on my own. So I would like to, first of all, thank NIH and HuBMAP for this opportunity to participate in this program. I'm very much grateful for that. And I would also like to thank the mentors I worked with here at the HiDive lab, Thomas, Morgan, and Lisa, as well as Niels, the head of the lab. You've all made this a very welcoming and educational experience, and I appreciate it. And finally, a few of the reference materials for this presentation.